All right, so let's look at example number 1. What if the domain and points of discontinuity of each rational function? Are the point of discontinuity removable or non-removable? And what are the x and y intercepts? So it's asking, again, for a lot of information here. First things first. Every single time you try one of these problems, the first thing you want to do is fully factor the numerator and the denominator. So looking at A, I see that x plus 3 is fully factored. I can't really take that any further. However, I can factor x squared minus 4x plus 3. So going ahead and factoring that into its most factored form, I can use xbox factoring. It's going to be a times c on the top, which is 3, and then my b value, which is negative 4 on the bottom. I need two numbers that multiply to equal 3 and add to equal negative 4. We end up with negative 3 and negative 1. Okay, so that means that our function, our new function, is y is equal to x plus 3 divided by x minus 3 multiplied by x minus 1. All right, at this point we can check to see if we have any removable or non-removable discontinuities. As you can see, I can't actually divide anything out from the top and the bottom because I don't have an x plus 3 in the bottom. So therefore, any discontinuities we get are going to be non-removable discontinuities, which would be vertical asymptotes. So in order to figure out what our points of discontinuity are, we have to set our denominator equal to 0. Our denominator is x minus 3 times x minus 1. We set this equal to 0. We end up with x minus 3 is equal to 0, and x minus 1 is equal to 0. Because if either of them equals 0, the entire bottom equals 0. Adding 3 to both sides, we end up with x is equal to 3. Adding 1 to both sides, we end up with x is equal to 1. So we have non-removable discontinuities at x equals 3 and x equals 1. So we figured out the first part of our equation. Now it says, what is the domain? And just like I talked about before, the domain is just the opposite of what this is. So the domain, x cannot equal 3, and x cannot equal 1. Part 2, done. Lastly, we want to figure out our x and y intercepts. So our x-intercept, that's where y equals 0. And y equals 0 when my numerator equals 0. Because if my numerator were to equal 0, that's 0 divided by something. And 0 divided by anything is 0. So therefore, if the numerator equals 0, the entire thing equals 0. So I can just set my numerator equal to 0 to find my x-intercept. My x-intercept, x plus 3, equals 0. So I end up with x is equal to negative 3 because I subtracted 3 from both sides. So my x-intercept is a point, so we need to write it as a coordinate. It's going to be negative 3, comma 0. And my y-intercept is even simpler to find. There's no real thought about that. It's just where x is equal to 0. So I go ahead and I plug 0 into all my x's. Y-intercept, so that's going to be y is equal to 0 plus 3 divided by 0 squared minus 4 times 0 plus 3. 0 on the top goes away, 0 on the bottom goes away, 0 on the bottom goes away. We're left with y is equal to 3. So my y-intercept is at 0, comma 3. And we found everything we need to find for this problem. Let's move on to B. B, we're doing the same thing. We really are just doing the same thing. First things first, we want to see if we can factor the numerator and the denominator. The numerator obviously factored already. X minus 5 cannot go any further. The denominator, x squared plus 1. You might think it's factorable. You might be wrong. X squared plus 1 is the sum of two squares, and as we discussed in class, you can never factor the sum of two squares. That's as far as you can take it. So you get to stop there, and that means since the denominator can't be factored, we can go ahead and set that equal to 0. X squared plus 1 is equal to 0 in order to find our discontinuities. Subtracting 1 from both sides, we get x squared is equal to -1. And we discussed this already too. X squared equals -1. Nothing I plug into x is going to equal -1 because x is squared, and anything squared is always positive. So this is as far as we can take it. It's never equal to 0, so we say no discontinuities. No discontinuities. So domain-wise, this is going to be all real numbers. So no discontinuities, the exact opposite of that is everything. So all real numbers is our domain. Next thing we need to find is our x-intercept. And as I said before, whenever you're finding your x-intercept, you want to set your numerator equal to 0. So x-intercept, numerator equal to 0, x minus 5 is equal to 0. Adding 5 to both sides, we get x is equal to 5, which gives us the coordinate 5, 0. And last but not least, we need to find our y-intercept. And our y-intercept is where x equals 0. Y-intercept, we're going to set our x is equal to 0. We end up with y is equal to 0 minus 5 over 0 squared plus 1. 0 goes away, and we're left with y is equal to -5 over 1, which is just -5. So our y-intercept is 0, -5. So far, so good. Now let's look at the last example on this problem. So y is equal to x squared minus 3x minus 4 all over x minus 4. Here, again, we always want to start out by seeing if we can factor the numerator or the denominator. Well, the denominator can't be factored. X minus 4 is as far as you can take it, but x squared minus 3x minus 4, definitely we can try factoring that. So let's look. We're going to have -4 on the top, we're going to have -3 on the bottom, and the two numbers -4 and 1. That means that our new function, our factored form of our function, is going to be x minus 4 multiplied by x plus 1 all over x minus 4. And right off the bat, you should see that x minus 4 and x minus 4, those can be divided out. So we don't have a non-removable discontinuity, we have a removable discontinuity because we can divide this out. So if I set x minus 4 equal to 0, that means that x is equal to 4, because we add 4 to both sides. We have a removable discontinuity. At x equals 4. All right. So far, so good. Next thing we want to do is we want to find our x-intercepts. I'm sorry, our domain. Our domain is the exact opposite of this. So the domain is x not equal to 4. Now our x-intercepts is where our numerator equals 0. And specifically, we divided this out. So all we're looking at is what's left over in our numerator, which is x plus 1. We can just say x plus 1 is equal to 0, and subtracting 1 from both sides, we get x is equal to -1. So our coordinate of our x-intercept is -1, 0. And lastly, our y-intercept, where x equals 0. Again, we can just use what's left over. Y is equal to x plus 1, which means 0 plus 1. And we're left with y is equal to 1, which gives us the equation 0, 1.